All right, so this is just 1.7 part 2. Today we're going to be solving nonlinear inequalities. Just means you have the x squared in there. When you do this, the easiest way to do this is to do it to where all of your okay, so what I do is I change my sign to be an equal sign. I move all my terms to be on the same side. Then from there, I factor to find your key numbers that you're working with. From there, I plot those numbers on a number line, and then I test points. Once I test points, that can give me my yes or my no on whether or not those are solutions or part of my solution. So if we look at the first example, we have x squared is less than or equal to 5x minus 6. I'm going to change this into x squared is equal to 5x minus 6, and then move my terms over. So I would subtract the 5x from each side. I have x squared minus 5x is equal to negative 6. Then I would just add the 6 to each side to get x squared minus 5x plus 6 is equal to 0. From here, I'm going to factor. So my terms of that 6, my two factors of that 6 that add up to be that negative 5 are negative 2 and negative 3. So this just factors out to be x minus 2 times x minus 3 is equal to 0. From here, I'm going to set each part equal to 0 and solve. So x minus 2 is equal to 0, x minus 3 is equal to 0. I add the 2 to both sides. I get x is equal to 2. I add the 3 to both sides. I get x is equal to 3. Now, from here, I can make a number line for myself. I have my two numbers there. Now I'm going to test numbers that are on, it's really three numbers that I'm testing. One on the left of my smallest number, one on the right of my smallest number, and one in the middle of those two numbers that are my key numbers I'm working with. So I'm going to pick easiest numbers that I can. Easy number that's less than 2, 0. Easy number that's greater than 3 can be 4. Between 2 and 3, I would go half. So I'm going to use 2 and 1/2, which is the same thing as 3 over 2. Or sorry, not 3 over 2. 5 over 2. From here, I'm going to test those three numbers that I chose to work with by plugging them in to my original inequality. So I'm going to use the x squared is less than or equal to 5x minus 6 with the 0 plugged in for x, then with the 5 over 2 plugged in for x, then with the 4 plugged in for x. All right, so plugging in the 0, I'm going to have 0 squared is less than or equal to 5 times 0 minus 6. For the 5 over 2, I'm going to have 5 over 2 squared is less than or equal to 5 times 5 over 2 minus 6. And then for the 4, I'm going to have 4 squared is less than or equal to 5 times 4 minus 6. So looking at the zeros first. The 0 squared is just 0. 5 times 0 is 0 minus 6 is negative 6. Is 0 less than negative 6? No. So your line will not go for this on that number, over that number. For the 5 over 2, the 5 over 2 squared is 25 over 4 is less than or equal to 5 times 5 over 2 is 25 over 2. And I'm going to just turn that 6 into 12 over 2 so I have a like denominator. If I subtract these, I'm going to have that 25 over 4 is less than or equal to 25 minus 12, which gives me 13 over 2. I'm going to rewrite this to where that 13 over 2 is something over 4, so I can just compare those numerators. So we have 25 over 4 is less than or equal to 26 over 4. 25 is less than 26, So this one is true. My line's going to go over where that 5/2 is. So it would be in here. If I test that 4, the 4 squared is 16. So 5 times 4 is 20. Minus 6 is 14. So 16 is less than or equal to 14. No, that's not a true statement. So my line will not go over where that 4 is. So from here, my interval notation to give my answer for this is just the 2, 3 with brackets on the 2 and the 3. If we look at our other example on this page, we have 2x squared minus x is greater than 1. I'm going to turn this into an equation and move my 1 over. When I move my 1 over, I'm just going to subtract it from each side. So I'm going to get 2x squared minus x minus 1 is equal to 0. Again, I'm turning it into an equation so that way it's easier for me to work this out. From there, I have an a that's larger than 1. So I'm going to multiply my 2 by my negative 1. That gives me negative 2. The factors of negative 2 that are going to replace the negative x are going to be a negative 2 and a 1. So this is going to be 2x squared minus 2x plus 1x minus 1 is equal to 0. I can factor by grouping. Factor out of 2x, factor out of 1. So that's 2x times x minus 1 plus 1 times x minus 1 is equal to 0. So this is going to be 2x plus 1 times x minus 1 is equal to 0. If I set both of these equal to 0, I'm going to have the 2x plus 1 equal to 0, as well as the x minus 1 is equal to 0. I subtract the 1 from each side. So we get 2x is equal to negative 1. And I divide by 2. So x is equal to negative 1/2. For the x minus 1 is equal to 0, I add the 1 to both sides. So x is equal to 1. So these are my two key numbers that I'm working with, the negative 1/2 and the 1. So on my number line, I'm going to have negative 1/2, I'm going to have 1. The number between the negative 1/2 and the 1, 0. Easiest number to work with 0. On the right of the 1, I can use 2. On the left of the negative 1/2, I can use negative 1. Again, pick the easiest numbers that you can work with. Plug these numbers in to your original inequality that was given to you and solve it. So you're going to have the 2x squared minus x is greater than 1 that you're working with. So we're going to plug in the negative 1. So 2 times negative 1 squared minus negative 1 is greater than 1. Then we have 2 times 0 squared minus 0 is greater than 1. And 2 times 2 squared minus 2 is greater than 1. From here, the 2 times negative 1 squared, the negative 1 squared is 1, times 2 is just 2. The opposite of negative 1 is 1. It's greater than 1. So 2 plus 1 is 3 is greater than 1. That works. So this would be shaded or have a line over it. For the 0, you have 2 times 0 squared. 0 squared is 0. 2 times 0 is 0. Minus 0. 0 minus 0 is just 0. Is greater than 1. That's not true. So that doesn't work. That doesn't get a line over it. For the 2 times 2 squared minus 2. The 2 squared is 4. Times 2 is 8. 8 minus 2 is 6, is greater than 1. 6 is greater than 1. That works. So our line would go over where that 2 is as well. So looking at this, you're going from negative infinity up to 1/2. As well as the 1 to positive infinity. Which is 10, 10. So with the next example that we have, so we have x minus 5 times x plus 4 is greater than or equal to 0. This is already factored for you. So the only thing you have to do is change this to be equal to 0. And then separate it to where the x minus 5 is equal to 0, the x plus 4 is equal to 0, and then solve for the x. So add the 5. So x is equal to 5. Subtract the 4. X is equal to negative 4. And then use your graph. So on your graph, you would have a negative 4. You would have a 5. The numbers in between the 4 and the negative 4 and the 5, as well as to the right of 5 and to the left of negative 4. So pick numbers. I would do negative 5, 0, and 6. Plug it in to the original, see if it's true statement. So I'm going to do 5 minus 5 times 5 plus 4 is greater than or equal to 0. 0 minus 5 times 0 plus 4 is greater than or equal to 0. And then 6 minus 5 times 6 plus 4 is greater than or equal to 0. So from here, the 5 minus 5 is 0, times 5 plus 4 is 9. 0 times 9 is 0. That is equal to 0. So this would be shaded. The 0 minus 5 is negative 5. The 0 plus 4 is 4. Negative 5 times 4 is negative 20. Negative 20 is not greater than or equal to 0. So the middle there would not be shaded. For the 6 minus 5, that gives us 1. 6 times 4 is 24. 1 times 24 is 24. That is greater than or equal to 0. So that would be shaded. Now, when you go to write your interval notation for this, you're going to have the negative infinity to negative 4, as well as the 5 to positive infinity. Now, because you're including all of these numbers, you're going to put a U in between them. It just means a union. You have two things. You have unions and intersections. Unions means the numbers that are all of them. So literally with these, if you end with, pretty much this is an or statement because your two lines go opposite of one another. If you end with an or statement, you have a union. If you end with an and statement where your lines go over each other or cross over each other, then it's an intersection and it would just be an upside down looking U. Okay, so ors, you get that U in between. The ones that connect get that upside down U in between. For number 2, in your extra examples, you have x times 2 minus 3x is less than or equal to 0. So again, I can just rewrite this to where x times 2 minus 3x is equal to 0. I set them both equal to 0, so x is equal to 0, and 2 minus 3x is equal to 0. The x is equal to 0. I don't have to do anything with that. That's one of my key numbers, though, so I need to remember that. For the 2 minus 3x is equal to 0, I'm going to subtract the 2 from each side. I get negative 3x is equal to negative 2. And then I divide each side by the negative 3 to get x is equal to 2/3. So from here, on my number line, I have 0, I have 1, this is going to be 2/3. I want the number in between the 0 and the 2/3, so I'm going to work with 1/3. A number to the left of 0 is -1. A number to the right of 1, let's say 2. So these are the three numbers I'm going to work with. Starting with the -1. I would have -1 times 2 minus 3 times -1 is less than or equal to 0. Then for the 1/3, I would have 1/3 times 2 minus 3 times 1/3 is less than or equal to 0. And then for the 2, I would just have 2 times 2 minus 3 times 2 is less than or equal to 0. To simplify these, inside my parentheses on the one on the left, I'm going to have the 2 minus 3 times -1. The 3 times -1 is just 3, so that's -1 times 2 plus 3 is less than or equal to 0. The 2 plus 3 is 5, so it's -1 times 5 is less than or equal to 0. That gives me -5 is less than or equal to 0. That's true. So anything to the left of 0 would have a line over it. For the 1/3, inside those parentheses, the 3 times -1/3 is just going to be -1. So that's 2 minus 1 inside the parentheses times 1/3 is less than or equal to 0. The 2 minus 1 is 1, so 1/3 times 1 is 1/3, which is not less than or equal to 0. For the 2 times 2 minus 3 times 2 is less than or equal to 0. The -3 times 2 is -6. So it's 2 times 2 minus 6 is less than or equal to 0. 2 minus 6 is -4. So 2 times -4 is less than or equal to 0. That's -8 is less than or equal to 0. This works as well. So to the right of this 1 would have a line over it. So once again, we have an OR statement. So we're going to have -infinity to that 0 with a union of that 1, or sorry, the 2/3, not the 1. The 2/3. I could have used 1 in my thing though. So this is 2/3, comma, infinity. Number 3, we have x squared plus 5x plus 6 is greater than 0. So with this one, we are going to change it to be equal to, and then also solve by factoring. So we are going to change this to be x squared plus 5x plus 6 equals 0. We find the factors of the 6 that add up to be the 5. We get 2 and 3. So this is going to be x plus 2 times x plus 3 is equal to 0. From here, we're just going to set both sets of parentheses equal to 0. So x plus 2 is equal to 0, as well as x plus 3 is equal to 0. We subtract the 2 from each side to get x is equal to -2. We subtract the 3 from each side on this one to get x is equal to -3. Using a number line, you have -2 and -3. You want a point between these two, so I'm going to do -2 and 1/2, which is the same thing as -5/2, as well as 0, because it's the easiest, and -4. So I'm going to plug these in, see which one works. So I have x squared plus 5x plus 6 is greater than 0. I'm going to plug in that -4 to be -4 squared plus 5 times -4 plus 6 is greater than 0. I'm also going to do the -5/2. So negative 5 over 2 squared plus 5 times negative 5 over 2 plus 6 is greater than 0. And I'm going to use the 0 as well. So that's going to be 0 squared plus 5 times 0 plus 6 is greater than 0. So working with my first one, I have that negative 4 squared, which is 16, plus 5 times negative 4, which is negative 20, plus 6 is greater than 0. The 16 minus 20 gives us negative 4, plus 6 is 2 is greater than 0. This one is true, so we would shade to the left of that 3. For the middle one, we have that negative 5 over 2 squared, which is a positive 25 over 4, plus 5 times negative 5 over 2, which is negative 25 over 2, plus 6 is greater than 0. We want to rewrite this to where we have all the same denominator. So it's going to be 25 over 4 minus 50 over 4 plus 24 over 4 is greater than 0. I could just combine my numerators, so that way I have 25 minus 50, which is negative 25. And then I am adding the 24 to that, which gives me negative 1 over 4. Oops. Is greater than 0. That doesn't work, so the middle would not be shaded. And then if we did the 0, we'd have 0 plus 6 is greater than 0. 6 is greater than 0. This one works. So to the right of that 2 would be shaded as well. Think about this as your interval notation now. Okay, so we are dealing with a greater sign, not a greater than or equal to. So with this, we are going to have an open circle on these numbers. Now, when you go to do your interval notation, you look at the way that you have this. You're going to negative infinity. You're stopping at that negative 3 with an open circle. So there's going to be a parentheses on that negative 3. Then you also have the negative 2 with an open circle, so there's going to be a parentheses, all the way to positive infinity, so parentheses on that as well. These two are not overlapping each other, so we said that would just be a union, so it just looks like a regular U in between these two interval notations. For number 4, we have x squared is less than x plus 2, so I'm going to change this to be x squared is greater than x plus 2. Move my x by subtracting it. I get x squared minus x is equal to 2. And then I subtract the 2 from each side to get x squared minus x minus 2 is equal to 0. I'm going to factor this. My factors of negative 2 that add up to be a negative 1 are a positive 1 and a negative 2. So this is just x plus 1 times x minus 2 is equal to 0. From here, I'm going to take that x plus 1, set it equal to 0. X minus 2 is equal to 0. I move the 1 over by subtracting it from each side to get x is equal to negative 1. I add the 2 over. I get x is also equal to 2. So using your number line, you have a negative 1, you have a 2. The number in between is 0 that we can use. To the left of the negative 1, we can use negative 2. To the right of 2, we can use 3. Plug these in to the original inequality and see which ones work. So we have x squared, so that's going to be negative 2 squared is less than x plus 2. So negative 2 plus 2. Then we have 0. 0 squared is less than 0 plus 2. And then we have 3, so 3 squared is less than 3 plus 2. negative 2 squared is 4, is less than negative 2 plus 2, which is 0. That's not true, so that doesn't work. We wouldn't shade to the left of that 1. For the 0 squared, that 0 is less than 0 plus 2 is 2. That works, so we would shade in the middle of the negative 1 and the 2. Now that you have that, you really don't need to move any further. However, if you did the 3 squared, you would get 9 is less than 3 plus 2 is 5. 9 is not less than 5, so that doesn't work either. So looking at this, you have what types of circles on the negative 1 and the 2? Your sign is just less than, so they're going to be open, which means your compound inequality here is an and statement since they connect. So you're just dealing with that negative 1 up to the 2, and it's going to have parentheses on both since it does not include the negative 1 or the 2. For number 5, we have 5x squared plus 3x is greater than or equal to 3x squared plus 2. So with this one, I'm going to start it again by changing it to be an equation. And then I'm going to move my terms over to one side. So I'm going to subtract this 3x squared from each side. I have 2x squared plus 3x is equal to 2. And then I subtract the 2 from each side to get 2x squared plus 3x minus 2 is equal to 0. For this one, when I factor it, I have to multiply my 2 by my negative 2. That gives me a negative 4. My factors of negative 4 that add up to be the 3 are going to be a positive 4 and a negative 1. So this is factoring to be 2x squared minus x plus 4x minus 2 is equal to 0. I'm going to factor by grouping now that I have the 4 terms. Factor out an x, factor out a 2. So this is x times 2x minus 1 plus 2 times 2x minus 1 is equal to 0. I form my 2 parentheses, one with the x plus 2, one with the 2x minus 1. I set them both equal to 0 and I solve. So x plus 2 is equal to 0. 2x minus 1 is equal to 0. I subtract the 2 from each side and I get that x is equal to negative 2. I add the 1 to each side. I get 2x is equal to 1. And I divide each side by the 2 to get that x is equal to 1/2. So on my number line, I'm going to have that negative 2. I'm going to have that 1/2. The number in between these that I can use is 0. To the right of the 1/2 is 1. To the left of the negative 2, I can use negative 3. I'm going to plug these into the original statement. Now, an easy way to do this, it's kind of like a shortcut. If you choose the number in the middle, just to do that, you would have 5 times 0 squared plus 3 times 0 is greater than or equal to 3 times 0 squared plus 2. If you do this correctly, you're going to have 5 times 0 squared, which is 5 times 0, that's 0. Then you have 3 times 0 is 0. Greater than or equal to 3 times 0 squared is just 3 times 0, so that's 0, plus 2 is 2. If we simplify this, this is just 0 is greater than or equal to 2. This gives us a false statement, so that middle part would not be shaded. It would just be the part to the left and the part to the right of those two numbers that are our key numbers on the number line. You're working with a greater than or equal sign, so these are giving you closed circles on both of these numbers. So when you go to write your interval notation, you're going from negative infinity up to negative 2, including that negative 2, so it's going to be a bracket, with a union of the 1/2 including the 1/2, so a bracket on the 1/2, up to positive infinity. So infinities always get those parentheses, which is why both the negative infinity and the positive infinity have parentheses on it, and then the -2 and the 1/2 are included, so those get brackets. For number 6, we're given x squared plus 2x is greater than 3. So I am going to subtract this 3 from each side and turn it into an equation. So I'm going to just have x squared plus 2x minus 3 is equal to 0. My factors of the -3 that add up to be 2 are -1 and +3. So this is just going to be x minus 1 times x plus 3 is equal to 0. From here, I'm separating it into x minus 1 is equal to 0, x plus 3 is equal to 0. I add the 1 to both sides to get x is equal to 1. I subtract the 3 from each side, and I get that x is equal to -3. So on my number line, I have I have -3, I have 1. I'm going to use 0 as my middle number, 2 as my number to the right of 1, and -4 as my number to the left of 1. From here, I'm going to have the -4 squared plus 2 times -4 is greater than 3. 0 squared plus 2 times 0 is greater than 3. And then 2 squared plus 2 times 2 is greater than 3. I'm going to check my 0, my middle, first. So that 0 squared is 0, plus 2 times 0 is greater than 3. 0 plus 0 is greater than 3. That does not work. So I know that my outsides most likely will work. So I'm going to shade to the left of that -3 and to the right of that 1. I just have greater than, so my circles are going to be open on the -3 and the -1. To use my interval notation, I'm going to have negative infinity, comma, -3 with a parentheses on both, with a union of positive 1, comma, infinity with a parentheses on both of those. For number 7, we have x squared is greater than or equal to 9. So I'm going to just change this to x squared is equal to 9. We're going to take the square root of both sides. Remember, when you take the square root of both sides, you are putting that plus or minus in front of your answer, so it's both +3 and -3. So on my number line, I'm going to use the -3 and the 3. The number to the left of -3 that I want to use is -4. The number in the middle is going to be 0, and the number to the right of the +3 is going to be +4. So I'm going to do x squared, so -4 squared is greater than or equal to 9. Then I have 0 squared is greater than or equal to 9. And then 4 squared is greater than or equal to 9. Well, the 4 squared and the -4 squared are both 16 is greater than or equal to 9. That is true, so we would shade in to the left of -3 to the right of +3. We're getting closed circles on both the -3 and the +3 since our sign says equal to as well, which just means we're going to go from negative infinity to -3 with a bracket with a union of bracket 3, comma, infinity, close parentheses. So this just means that x is less than or equal to -3, or x is greater than or equal to +3. For 8, we have x plus 3 squared times x plus 1 is greater than 0. So for this one, I can separate it as x plus 3 times x plus 3. And I also have that x plus 1 is greater than 0, I'm going to turn it into an equation, so I'm just going to set it equal to 0. From here, I'm going to have x plus 3 is equal to 0, x plus 3 is equal to 0, x plus 1 is equal to 0. Solve for all of them, subtract 3 from each side. I get x is equal to negative 3. Do the same with the other. And then subtract the 1 from each side. So with my two numbers that I'm working with, I'm going to work with the negative 3 and the negative 1 on my number line. The number to the left of negative 3 that I want to use is going to be negative 4. In the middle, I'm going to do negative 2. And then to the right of that negative 1, I'm going to use 0. So I'm plugging them into my original inequality. So I'm going to have negative 4 plus 3 squared times negative 4 plus 1 is greater than 0. Do the same with the negative 2. So negative 2 plus 3 squared times negative 2 plus 1 is greater than 0. And then use the 0. So 0 plus 3 squared times 0 plus 1 is greater than 0. Look at the first one. You have that negative 4 plus 3 squared times negative 4 plus 1 is greater than 0. So that negative 4 plus 3 is negative 1 squared. Negative 4 plus 1 is negative 3 is greater than 0. Negative 1 squared is 1 times negative 3 is greater than 0. So from here, I'm just going to get a negative 3 is greater than 0. That does not work, so I'm not going to shade there. With the 2, the negative 2 plus 3 is 1 squared times negative 2 plus 1 is negative 1 is greater than 0. This is going to give me 1 times negative 1, which is negative 1 is greater than 0. That one does not work. So let's try the other one. So the other one, we have 3 squared times 1 is greater than 0. 3 squared is 9 times 1 is greater than 0. So that's just 9 is greater than 0. That one works. So we would shade to the right of that negative 1. Let's try this negative 4 again. So I'm just going to check my answer by redoing this just to check to see if that was correct. So negative 4 plus 3 times negative 4 plus 1 is greater than 0. Okay, negative 4 plus 3 is negative 1 squared. Negative 4 plus 1 is negative 3 greater than 0. The negative 1 squared is 1 times negative 3 is greater than 0. So that's negative 3 is greater than 0. And that one is not true. So if we look at this, the only one that works in this case is that 0. So we're going to have an open circle on that negative 1, and it's going to go to a positive infinity, which means our answer is just negative 1 comma infinity in parentheses.